Hey, welcome to Build 2. This is where we do the kind of stuff that is going to get you through mathematics, get you through science-based classes, engineering school, whatever it is. And in this one, we are going to go through the calculations that I did on the wind power on my truck video, where I actually measured everything and proved that there was, in fact, some energy there being wasted badly enough on the front end of the Bronco that we were able to recover some of that with that fancy turbine that we built. But before we get into this, you might want to go watch my video on the math engineers use most, I think it is. Has a picture of a pizza there on the thumbnail. And it's what I've been told is called dimensional analysis, that we're going to use the units of all of the gallons of gas and the energy that's in it and the miles, the distance that we went, and calculate the kilowatts that it took just to drive down the road. And it's a pretty straightforward calculation, man. This kind of stuff will get you, I mean, this is like half of engineering school, is being able to do this. If you can do this, man, it just makes your life so much easier. Feel free to just follow along with what I'm doing and maybe you'll just figure it out. But if any of it's confusing at all, go back and watch that pizza video, because I really walk it through and drive it home how to do this. So the knowns that we started with, let me just write them down. So we were getting an average of 20.04 miles per gallon according to that gauge. Gauge doesn't lie, it just says what the engine is using. Miles per gallon, or here in the States we'll say MPG, but what that really is miles divided by gallons. So we got, for 1 gallon of gas, we got 20.04 miles. And we need to know how much energy is in a gallon of gas. And I went and looked this up, and here's what I got. When I looked up how much energy is in a gallon of gas, I got a number of websites saying it was anywhere from 120 to 140 million joules in a gallon of gas. And I found one that was very specific, that was 131,760,000 joules, or turn that into kilojoules, 131,760 kilojoules. But okay, joules, and how do we make use of that when we're trying to work with watts? Well, when you get into physics, they talk about a joule being a joule is an amount of energy. When we talk about energy and power, the best example that I've heard is you got a job and you're getting paid by the hour. The power is your pay rate, so how much you're getting paid per hour. But the energy is what you take home at the end of the day, is the amount of money that you've got after working those 10 hours. And it's the same thing here, that the energy is joules, or a unit of energy. And so joule is an amount that's in the gallon, but we want watts are the rate. It's that power, it's that payment per hour kind of a thing. And a joule is a watt second. So it's watt is the rate, and in 1 second, so watts times 1 second, just like when we measure power in kilowatt hours, it's watts times hours. Well, a joule is a watt second, so we can say that this is, we can cross out the kilojoules and say kilowatt second. So it's that simple. And that's the little piece of knowledge that you just pick up in the physics classes. I'll touch on a number of other those. With one of my favorites is Newton's kilogram meters per second squared. I'm gonna dive into that stuff in future videos and just crush that where you learn to love it. So 1 gallon has this many kilowatt seconds, and we've got gallons, we've got miles. I think this is everything we need to be able to find out how many watts we're actually burning. Like I said in that units video, when something is equal to something else, you can put it over itself and just get it's equal to 1. So we can write that out just like that. And so when I have 20 miles per gallon, I can flip it. I can put gallons on the top. I can put miles on the top like it is. But what's going to be most useful for us is to have gallons on top. So we're going to say 1 gallon per 20.04 miles. Now to cancel out these miles, we need the other something with miles on the top, and this is making me realize there's a piece of information I didn't have, is the speed that we were going. This is what the speed sign says as we were ripping by them. The speed limit was 55 miles per hour, and now I can take this and put it down here, and now I have miles over miles, which cancel each other out, and we're left with gallons an hour. Now, what else do we have? We don't want gallons. We want to end up with kilowatts in the numerator in the top. So how do I get gallons out of here? Well, I've got gallons and kilowatt seconds. So let's see. I want the gallons on the bottom to cancel out the gallons on the top. So let's rewrite this, the reciprocal of this down here. Reciprocal is when you flip something upside down, and because it's over itself, it's equal to 1, you can do that. Okay, and just like I said, we've got gallon over gallon, bang, bang, gone. Now we've got kilowatt seconds per hour. Well, wait a minute, seconds and hours, that's no good. So which one do we want to go with? We can either convert hours to seconds, or we can convert seconds to hours. Let's see, which one do we want to cancel out here? Let's turn seconds into hours. So seconds, 3,600 seconds in an hour. Now we have seconds cancel, and guess what? We have hours that cancel as well. Bang, bang. What are we left with? Our only unit is kilowatts. This is exactly what we wanted. So now this is basic math. It's just multiply everything across the top. We can just put an equal sign over here. Multiply everything across the top, multiply everything across the bottom. Let's do it. 55, 131,760. Times, that is, woo, big number. What's on the bottom? 20.04, 3,600 times, okay, we divide those two. Oh, carry the units. Kilowatt, 100.45, blah, blah, blah. Kilowatt. Now, wait a minute. I said we were doing 25 kilowatt, and this says 100 kilowatt. Oh my gosh, the numbers must be terrible. No, we said when you look up the efficiency of a gasoline engine, it says anywhere from 20 to 35%. I think they said the diesel engines can get as high as 40% efficiency. The gasoline engines that are at 35% efficiency, we're talking direct injection, we're talking turbochargers, but I've just naturally aspirated pickup truck engine from 2004. I'm not going to say it's the bottom end of that 20%. I'm just assuming, because I tried going to the Ford website, going to Triton, hey, what's the efficiency of this engine? They'll give you peak horsepower, peak torque, that kind of stuff, but it's not telling me the efficiency of the engine. It's like, all right, fine. So I'm just going to assume 25% efficiency. So we get to multiply this times basically 0.25. And that's where I came up with my, so 25 kilowatts. And people had told me in the comments that, hey, I've done an electrical vehicle conversion on a pickup truck, and it takes anywhere from 15 to 20 kilowatts just going down a flat road at highway speeds. Well, I didn't ask him exactly what model it was, but kind of makes sense. They're probably not going to EV convert a jacked up Bronco with big fat tires on it. Pretty much that's a good gut check to say, okay, mine takes a little bit more energy going down a flat road than a lighter truck would. But basically the reason I do this is I remember my chemistry teacher in high school just doing this stuff over and over again, doing units, and I just wasn't getting it. It wasn't clicking for me. It didn't click for me until I got to college, and it was like my second or third term in physics class, and it finally clicked, and I'm just like, how come they didn't teach it to me this way from the start? This is driving me nuts, and it's ridiculous that it took me that long for it to click. I'd love to go back to myself and see if me presenting it in the way that I'm presenting it to you in my pizza video and in this, I'd love to see if that would have made it click a lot sooner. I'd like to think that it would, but I don't have that ability to do that. So, but hey, that pain motivates me to help you guys out. I'll tell you a quick story. I had a strength of materials class that I had not studied for, and I got in there and I was supposed to memorize the formulas for it, and I hadn't had time. I was working on physics or whatever other homework I was taking at the same time. When you're rushing through as many college credits as you can handle, not very smart to do that. But I got in there and I realized I was able to use the information. You know, it wasn't miles per hour and kilowatt seconds and that kind of stuff, but I aced the front half of that exam. Was the whole page. I aced it. I got 100% on every one of them, even though I didn't know the formulas, because I was able to take the strength, the stresses, the whatever it was of the material, and I was able to calculate everything just by doing this. And then to tell you how bad of a test taker I was, the backside was true false, and there were, I want to say 7 or 8 questions, and I got one of them right. I should have just marked them all true or all false, but I didn't know that. But I was just, you know, sometimes true false questions or multiple choice are just written in a cryptic fashion. They don't work well with my brain. Let me do something longhand, and I'll show you I understand the material. But there you go. Hopefully that wasn't too boring for you guys. This is it. I'm telling you, if you can get this down, this is a large chunk of science and engineering classes, is being able to work your units. And it's actually, this is probably one of the few advantages of going to classes in the States where you're forced to grow up with miles per gallon, inches and feet, and I mean, you know, 5,280 feet in a mile, all these crazy units. And then you get to get into the metric system of the watts and the meters and grams and kilograms and all that stuff. And going back and forth, boy, it just hammers it home in a way that you're just not going to get that exposure in Europe. So maybe that's why I love this, is that it was this cryptic jigsaw puzzle of units growing up here in the States that I just learned to get really good at, and now I can do it in my sleep. So hopefully that helps somebody. Always check back. I'm always trying to put helpful stuff on this build too for those of us technical people that just need a little extra help. So thanks for watching. See you next time.